Hi, Assalamualaikum everyone. Hi. Okay. So now we are going. So now we are at the second part of our lecture for this week. So we are going to look at chapter 5.2 liquids. So the learning outcomes that we are going to cover for this chapter is the first one. We are going to relate the properties of liquid to the intermolecular forces, molecular arrangement, and molecular motion in explaining shape, volume, surface tension, viscosity, compressibility, and diffusion. So there are actually 5 properties of liquid. Okay? Alright, and then we're going to explain the vaporization process, the condensation process, based on the kinetic molecular theory and the intermolecular forces. We are also going to define what is the vapor pressure and the boiling point, and we're going also to explain the boiling process, and we're going to illustrate the relationship between the intermolecular forces and the vapor pressure and the temperature. So, we're going to look at this. Okay, so have you ever wondered why can a water strider walk on the water? Tahu tak water strider tu apa? Macam apa? Alah, yang macam apa water strider BM ulat air bukan? Apa tak? Tapi kan nampak kan biasa ada ulat yang boleh jalan-jalan atas air tu kan? Why a water strider can walk on water? Can you walk on water? Tak Okay. And then why the water beads on waxy surface such as an apple leaf or a freshly waxed car after a rainfall? Kenapa ada macam embun-embun air atas waxy surface? So we are going to know the reason why after this lecture session. Okay, so basically there are 5 properties of liquid. The first one is the volume and shape. The second one is the compressibility. The third one is the diffusion. The fourth one is the surface tension. And the fifth one is the viscosity. Okay, now we are going to look at the properties of the liquid one by one. So first one, we are going to look at the volume and shape. So, liquid has a definite volume but not a definite shape. Dia ada volume yang tepat but dia tak ada shape yang tepat. Okay, so the liquid particles, they are arranged closely but not rigidly, but not as rigid as solid. And the molecules are held by an intermolecular forces, but they still be able to move freely. There are the forces between them, but they still can move freely. Okay, and a liquid flows to fit the shape of its container and is confined to a certain volume. So what is meant by that is liquid has a fixed value, but the shape is not fixed, which means that they take the shape of its container. Alright, second, compressibility. So in liquid, the particles are packed closely together. So thus, there is a very little empty space there. So that is why liquids are much more difficult to compress compared to gas. If gas, there are really a lot of spaces between the gas particles. So that's why we can easily compress the gas. Like if you blow up the balloon, the dalam balloon ada gas, right? So we can compress the balloon easily compared to when we want to compress the liquid inside a balloon. Okay, this is why liquid is much more difficult to compress compared to gas because the space between the liquid particles is closely packed together compared to the gas particles. Third, diffusion. So, liquid diffuse slower than gas due to, first, the molecules are closely packed compared to gases. So, bila molecules tu closely packed, dia punya diffusion rate slower compared to gas sebab dia punya space kecil sangat kan. So, bila nak diffuse tu dia ambil masa. Okay. Second, liquid has lower kinetic energy than gases. Compared to gas has like quite a high kinetic energy. They can move really fast compared to the liquid. Okay, and C, liquid has stronger intermolecular attractive forces between the molecules compared to the gas. So, bila ada stronger intermolecular forces, they take more time to diffuse. Okay, the diffusion rate is lower. So there are three reasons why the liquid diffuse slower than the gases. Okay. Next, surface tension. So surface tension is the amount of energy required to stretch the surface of a liquid by a unit area. Okay. So actually, liquid molecules, each and every one of the liquid molecule if we look at the picture, they all experience the intermolecular attractive forces in all direction. Atas, bawah, tepi, depan, belakang, semua dia ada. Dia experience the intermolecular forces by their neighboring molecule. Maksudnya, contoh, for example, this molecule dia ada experience forces dekat atas, bawah, tepi, depan, belakang of their neighboring molecule. Okay. So however, molecules at the surface, molecule at the surface are pulled downwards and sideways from the neighboring molecule. So bayangkan, imagine the surface, the water molecule at the surface, right? So the neighboring molecule dekat sebelah tepi ni, they pull, and then the water molecule down pun pull downward. So dia ada tension dekat situ, tension at down and tension downwards and tension dekat sideways. So bila banyak tension, the more the tension, the more the stronger the intermolecular forces attractive, the higher the surface tension. Lagi teganglah permukaan water surface area itu. Okay, so stronger the intermolecular attractive forces, the higher the surface tension of the liquid. Okay, so now we can answer the question why the water striders can walk on the water. Disebabkan water ada surface tension. So when water has a high surface tension, the water strider can walk on the water. Cuba you try walk on the water, boleh tak? Okay, of course tak boleh sebab kita berat water strider dia ringan, so dia tak affect the surface tension of the water. Alright. So disebabkan of the intermolecular forces between the surface, between the molecules, so the water molecules, what we call it, has forces dekat sideways dengan downwards of the surface water molecule. So the surface will tighten like an elastic film so that the water strider can walk on it. Okay. So now, let's think. What happened to the surface tension of a liquid if its temperature increases? So we usually relate the temperature with the kinetic energy, right? So when the temperature increases, the kinetic energy increases, which means the water molecule will move faster. So bila the water molecule move faster, what happened to the intermolecular forces attraction between the water molecule? Become weaker. So the surface tension decreases, right? So the answer is when the temperature increases, the surface tension decreases, because when the temperature increases, the molecules become more energetic and will break up some intermolecular forces. So bila they break up some intermolecular forces, they reduce the surface tension on the water molecule punya surface. Okay? Alright. So this is the conclusion lah. Temperature increases, molecular motion increases, hence the intermolecular forces becomes weaker, hence the surface tension decreases. Okay. Now we look at the last properties of the liquid, which is viscosity. Okay. So what does it mean by viscosity? Viscosity is the resistance, the ability of the liquid to flow. So the higher the viscosity, the harder for liquid to flow. Lagi likat lah. So kelikatan. So viscosity ni kelikatan. Okay. So Yeah, so the greater a liquid's viscosity, the more slowly it will flows. Okay, so it says that the viscosity will decrease as the temperature increases because it depends on, also the viscosity depends on one, the size of the molecule. So the higher the molar mass, so the bigger the molecule, right? So the bigger the molecule, the higher the molar mass. So the more resistance there. So kalau banyak resistance, lagi viscous the liquid, lagi susah dia nak flow. Okay, second, the strength of intermolecular attractive forces between the molecules. So if there is strong attractive forces between the molecule, so the higher the viscosity. Yelah, bila lagi kuat tarikan, lagi susah lah nak flow kan, lagi likat lah liquid tu. Okay? Alright. So, as a conclusion, we can see that for solid, solid dia biasanya dia punya shape and volume maintain, dia tak berubah, and there are no, so solid cannot be compressed, they are not able to flow, and the density is high, and the motion of the molecule within the solid, they just vibrate about the fixed position, and there is no surface tension. There are no relationship on the surface tension. So on liquid they conform to the shape of the container, and the volume is fixed lah. Okay, and the compressibility is very low, and they can flow. They are able to flow moderately, and they have high density as well. The motion of the liquid, they can move slide past one another freely, and then liquid has the high surface tension. Okay, for the gas conform to shape and the volume of the container as well, and it's very high compressibility, and it has the ability to flow very easily. So it has low density, and it has a very free motion. For gas, it don't have a relation on the surface tension at all. So only liquid lah ada surface tension. Alright. So now we are going to look at the vaporization. So we have looked at the 5 properties of the liquid. So now we are going to look at what liquid does lah. So liquid can vaporize. Okay, so what is vaporization process? So vaporization process is a process in which molecules escape from the liquid state into a gaseous state through a surface. So listen to my words carefully. So the vaporization process occurs only at the surface of the liquid, and it can occur at any temperature, at any pressure. Okay, so vaporization process can occur at any temperature and at any pressure, and it only occurs at the surface of the liquid. Alright? Okay. So look at this phase change lah. So when the liquid change into gas state, it called vaporization. And when the gas turns back into the liquid, we call it condensation process. So the vaporization process and the condensation process is happening at an equal rate, at the same rate. So we are going to look at that after this. Okay. So look at the vaporization process. So the vaporization process is a process in which liquid is transformed into gas. Okay, so based on kinetic molecular theory, we can say that the molecule in a liquid can move quite freely. So each molecule actually possesses different magnitude of kinetic energy. So when the kinetic energy is sufficient enough to overcome the attractive forces that bind them, the molecules will loosen themselves and be evaporated off. Okay, maksud dia dalam bahasa Melayu macam ni. So, setiap molekul dalam liquid ni dia boleh move, right? And dia actually ada different magnitude kinetic energy. So, maksudnya dia certain molecule dia boleh jalan laju, certain dia boleh slowly move. Okay. So bila dia punya kinetic energy ni cukup untuk diorang overcome attractive forces yang ada dengan diorang ni, so diorang boleh lose themselves and diorang boleh naik ke atas, dia akan boleh evaporate as a gas phase. into a gas phase, into a gas state. Boleh faham? Okay, so dia boleh occurs in two ways. The first one is through the evaporation and the second one is boiling. Okay. So there are three factors that affect the vaporization rate. The first one is the surface area, the second one is the temperature, and the third one is the intermolecular attraction forces. Okay, so now we look at the first factor. So the larger the surface area, so the bigger the chance for the molecule to escape from the water surface. So maksudnya evaporation rate increases. Yalah, sebab lagi besar surface area, lagi senang molecule nak escape from the water surface. That's why the evaporation rate increases. Okay, let's look at temperature. So at higher temperature, more molecule possess higher kinetic energy. Kan? So more molecules have enough energy to escape from the surface of the liquid. Thus, the evaporation rate increases. Okay, and last one, intermolecular attraction forces. So the weaker the intermolecular attraction forces, the faster the evaporation rate. Yalah, sebab dah bila intermolecular forces lagi kurang, senanglah dia nak escape from the surface of the liquid to the gas state. Okay, so that's why the evaporation rate increases. Alright, so let's look at the condensation process. So what is the condensation process? So the condensation process is a process in which gas is transformed back into liquid. Tadi vaporization, liquid to gas state. Condensation process, gas state to liquid state. Okay, so based on kinetic molecular theory, some of the vapor molecule ke atas tadi tu may lose their kinetic energy during the collision. Okay, tadi, just now, when the liquid escape from the surface into the gas state, they will become vapor molecule. So this vapor molecule, they have their own kinetic energy and they will collide with each other. So at some point, this vapor molecule may lose their kinetic energy during the collision. So then they will not have enough energy to remain as the vapor molecule sebab dia dah lost energy kan. So they don't have enough energy to remain as the vapor molecule. So they reach the surface of the liquid and trapped by the attractive forces. So they will become liquid balik. Okay, sebab dia jatuh balik kepada surface of liquid and jadi liquid balik and they dah trapped by the attractive forces. Okay, so if they cannot overcome the attractive forces, so this vapor molecule akan return as liquid molecule. So bila tadi vapor molecule tu sampai dekat surface of the liquid, dia akan ada attractive forces bind dengan diorang. So kalau diorang tak boleh overcome the attractive forces, this vapor molecule akan return as liquid molecule. Okay, so this process we know as condensation process. Okay, so the dynamic equilibrium. So the rate of the vaporization is equal to the rate of the condensation process. So the rate of the liquid become gas and the gas become liquid is at the dynamic equilibrium state. Okay, like rate of the vaporization is equal to rate of condensation. So, which means that the pressure of the vapor is constant at that temperature. Yalah, sebab dia punya rate sama kan, dynamic equilibrium. So, pressure pun constant at the temperature. Okay, so this is the vapor phase or the gas phase. Dia ke atas and then this is the liquid phase. Okay, at the dynamic equilibrium, contohnya, when two liquid molecule escape to form a vapor molecule, another two vapor molecule akan captured balik masuk kepada liquid phase. So dia berlaku dynamic equilibrium lah. Dua masuk, dua keluar. Dua masuk, dua keluar. Contohnya, for example. Okay? So, let's look at the vaporization versus condensation. So, some molecules at surface have a high enough kinetic energy to escape. Sebab you have to remember that the vaporization process occurs only at the surface of the liquid. So, some molecule at surface have a high energy to escape the liquid. So the number of vapor molecule will increase and the pressure of the vapor will increase sebab liquid molecule dah escape kat gas state kan. So number of vapor molecule increase lah. So bila number of vapor molecules increase, the pressure of the vapor increase. So at the same time, okay, the vapor molecule yang dekat atas tadi ni, they will collide with molecules kan at the surface. And they will attracted and then they will condense. Dia boleh jatuh ke bawah balik. So dia dah lose energy masa dia collide tu, right? Okay, so kat sini, the vapor molecules increases and the rate of condensation slowly increases. So eventually, the rate of vaporization is equal to rate of condensation. Macam tadi lah saya bercakap. Dua liquid go into gas phase, dua gas phase punya molekul jadi liquid balik. Dia berlaku pada rate yang sama, at the same rate. So by having said that, we can say that the system is at dynamic equilibrium. Okay? Alright. So now we are going to look at what is vapor pressure. Tadi kita tengok apa tu vapor pressure, right? So vapor pressure is the pressure exerted by vapor in equilibrium with its liquid in a closed container. So this happen inside a closed container. Okay. Maksudnya pressure daripada vapor molecule dengan liquid yang dekat equilibrium dynamic state tu ada pressure between them. Okay? Alright, tu kita panggil vapor pressure. So, in an open system, vapor molecule which evaporate will diffuse away. Yalah, bila dekat open system, vapor molecule tu the liquid dia go into the gas state, dia jadi vapor molecule, they will evaporate and will diffuse away to the surrounding. Okay, however, in a closed system, the vapor molecules cannot leave the surface. Dia cannot escape the system. Bila dia from liquid to gas, and then dia akan form balik gas to liquid. So dia ada equilibrium state dekat situ sebab dia tak boleh nak escape to the surrounding. Okay, so dekat situ ada vapor pressure between the vapor in equilibrium with its liquid. Okay, so now, when the vapor molecules cannot escape from the system, they will remain in the container. Yang kuning-kuning ni vapor molecules, okay? Okay, they will remain in the container. So, they will be in contact with the surface of the liquid at constant random motion. Like kuning ni, they collide with the walls and they collide dengan surface of the liquid. So, when they continually strike, okay, the wall of the container and the other vapor molecules and the surface of the liquid molecules, ada pressure exerted. So the continuous strike of the vapor pressure with the wall of the container, with the other vapor molecules and with the surface of the liquid molecules will exert a pressure, and this is what we call a vapor pressure. Okay, so this is only happen in the closed system. Alright. So, for a more volatile liquid yang senang, what we call it, meluap, it will exert a greater equilibrium vapor pressure than a less volatile liquid at the same temperature. Kenapa? Sebab for a volatile liquid, the attractive forces between the molecules are weaker compared to the non-volatile liquid. That's why dia senang meluap, dia senang evaporate. Okay. So for a less volatile liquid to vaporize and its vapor pressure to reach the atmospheric pressure, it must absorb more energy. So untuk less volatile liquid, the vapor pressure it needs more energy, okay, to reach the atmospheric pressure. Okay, so thereby it boils at higher boiling point. That's why volatile liquid has lower boiling point compared to the less volatile liquid. Sebab less volatile liquid needs more energy, needs higher temperature to absorb more energy to vaporize. Okay? Okay, next we go into boiling point. So what does it mean by boiling point? So boiling point is the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure. So, kalau tadi vaporization process, dia occurs at any temperature, at any pressure, and they only occur at the surface of the liquid. Untuk boiling ni dia occurs at specific temperature and specific pressure, and boiling ni dia occurs throughout the liquid. By means, dia occurs dekat surface and dekat inner part of the liquid as well, not just the liquid surface. Okay. So biasanya ini pressure lah yang dia akan ada boiling point 1 atm, 0.5 atm. So boiling point of water ni the difference at different pressure. Dia ada specific boiling point at the specific pressure. So at sea level, since the pressure is 760 torr, high pressure, the boiling point is 100 degrees Celsius. Okay. When we going up higher, like contohnya Mount Everest, so at the higher altitude it has lower pressure. So dia punya boiling point decreases 72 degrees Celsius only. So when you going up onto the mountain, on the Mount Everest, you want to boil water, your water can be boiled at 72 degrees Celsius. Okay. Alright, so define normal boiling point. So normal boiling point is the temperature at which a liquid boils when the external pressure is 1 atm. That is the vapor pressure is at 660 mmHg. Okay. So boiling point is a process of change from liquid to gases which occurs at the surface and inner part of the liquid. Okay, nampak kan? Tadi vaporization occurs dekat surface part of the liquid saja. But boiling, the process occurs at the surface and the inner part. Senang cerita, throughout the liquid. Okay? So the bubbles will be observed and the temperature remain constant during the boiling process, even heat is supplied. So, okay. And it occurs at a specific temperature and pressure. So different with the vaporization process tadi. Vaporization process, dia only occurs dekat mana? Dekat any temperature at any pressure. Okay? Boiling at the specific. Alright. So look at this example. Dikata by referring to the graph, what is the boiling point of water when the external pressure is 187.5 mmHg? So 175 mmHg is between 100 and 200. This is the pressure lah. So kalau kita tengok, this is the temperature of the water. So dekat sini possibility dia, dekat sini lah dia punya boiling point dia. So dekat sini 187.5 mmHg is equals to 175.5 torr. So dekat sini we can see that here is the pressure 187.5. Pergi sini. So this is the temperature. So boiling point of water at 187.5 mmHg is 65 degree Celsius. Okay, jadi specific lah kan kat situ. Specific temperature and specific pressure. Okay, so now it's quiz time. So this you have to answer in the comment section below. Okay, so give the main difference between boiling and evaporation. Okay, what is the main difference? Oops, sorry, salah type. Guys, sorry. Give the main difference between boiling and vaporization. Sama lah tu actually. Evaporation dengan vaporization sama je sebenarnya. Vaporize to evaporate juga lah kan. Okay, tapi betul tu. So, apa beza boiling process dengan vaporization process? Ada dua tadi saya sebut. There are two difference. So, state your answer in the comment below. Alright. So, that's it for our lecture for this week. So this is the second part of the video. So don't forget to watch the first part of the video dulu, baru tengok this part, the second part of this video. Okay, so yeah, I will see you guys next week with the 5.3 solid. Okay, so yeah, that's all for today. We will see you next week. Okay, I hope that you guys enjoy this video, and I hope that you guys find this video helpful to improve your understanding on this chapter. So yeah, bye bye, thank you, Assalamualaikum, and a very good afternoon. Actually, it's already evening. Okay, bye bye.